Hello, everyone. Can you hear me? Yep. Good. Okay. Some time ago, I went to a client to start a new project, and I got a statement of work saying something machine learning. And it was, well, probably a year ago, and machine learning meant do some cool stuff with data, and we don't want to know what you're doing exactly, but just do something that magically tells us what's there. And so I went to a client. And I asked, like, I've done what a consultant would do while going to a client site. I just asked about more details of what's going on. And I was presented with 3.5-inch, 1 terabyte USB drive, saying, "Hey, this is a project. These are our project files. It's kind of full, and it's a mixture of Excel files, documents, CAD drawings, PDFs." And I looked at it, and I just came to realization that I might be looking at my first big data project. I'm looking just a huge amount of data that probably I'm not able to fit on my machine, that I have no idea what's there. I can't expect any structure, and I have to analyze it somewhere. And so they went on saying, actually, we have no idea what's inside. We have no idea how many of these files are relevant. By the way, we have 300 other projects like that, so this is just a small sample. So by that point of time, I knew that I was looking at the big data project. And it turned out it wasn't a machine learning at all. It actually made me to build my first data lake. So my name is Dom. I'm a consultant at Redify, and I'm kind of sitting with close to a team that does data work for our clients. And I want to tell you about how cool it is to be a data engineer in 2018, and how many things you don't have to think about if you want to run your experimentations in data lakes. So the plan is fairly simple. First of all, I would like to put another definition of what data lake is, because when I say data lake, probably I would like you to understand what do I mean. And if you just search for what data lake is, you will find so many definitions talking about, whether this is a Hadoop or storage or design pattern, something else. Then we're going to talk a little bit about how to build a data lake in terms of what are the flavors when you're building a data lake, and eventually how to build a serverless one, because we need a catchy keyword. Funny story, when I was building this deck, PowerPoint has this thing called design ideas. So you can put any content, and you can press these design ideas, and it will come up with icons and style and stuff like this. And it's like, okay, that's nice feature powered by machine learning somewhere in Microsoft Cloud. So I'm just going to use it. And I typed data lake, and duck came out, and the duck is going to stay. Okay, so let's go back on track. So first of all, I would like to talk about what I think is a data lake. Many people might have their own definitions of what data lake is. This is the definition that helps me to build data lakes. So first of all, I understand data lake as a design pattern. I want to completely disconnect thinking about data lake from things like Hadoop or EMR or HD Insight or Databricks for now. This design pattern is mostly about data processing. And this design pattern requires two things. First of all, large and scalable storage that allows you to put data in its raw state, and scalable and multi-protocol analysis. So something that allows you to actually run your jobs on this data, regardless what the data might look like or where it might be coming from. Clear so far? Cool. So now when we know what data lake is, how we can build one. In order to build a data lake, it's like any other software work. You have to have an idea. You have to have a purpose why you're building a data lake. And And the goal of I need a data lake because I need to dump data somewhere, it's not a valid one. It's like, sometimes clients are coming or people are coming and saying, oh, we just collected this data over the last couple of years and we want to do something about it. It's literally like saying, oh, we just collected this pile of laptops, over a couple of years and we want to do something about it. I have no idea what's the quality of this thing. I have no idea how can I use it, and I have no idea how you want to use it. So the first thing when you're building or designing your data lake is actually start from the end and understand what are you after. In my case, when I was with a client, they actually want to index data. They want to have a very quick. They wanted to have a feature that would allow them to quickly index through a bunch of the project documentation and put them into the right document to the right page. So in case of their teams were looking for something, very, very quickly, probably we were looking at 200 to 300 terabytes of data. It would just immediately pull it, kind of like an intranet Google-like thing. So first of all, you have to understand what you're after, because otherwise, there's a high chance that you might be dumping data without any purpose. And this kind of data might quickly become a liability. And if you are putting some kind of data that, for example, contains the privacy data or privacy information or something like that, you want to make sure that you have a right control and this data is put in the right place on purpose and it has the right policies around it. So once we know what we're after, then we're looking for supporting data sources. You go around and say, OK, so for example, if I ask you, how do you actually get your project documentation? Where are you looking for? Is it a file system? Is it some kind of project documentation software? Is it, I don't know, your emails or something like that, right? And then you build a data lake. So data lake has those two components. Something that allows you to stage data, or maybe not stage data, put the data in its raw form. And something that allows you to run analytical jobs. In a couple of minutes, I will go into how that actually is possible using things like Azure Data Lake Analytics. But for now, let's just have this very simple understanding of what we're after. We start with the use case, then we look for data sources, and then we figure out actually what is the right piece to put in the middle. So going more into details, when I think about data lake, I think about these two components. One is a storage, and second one is analytics. And storage should allow you to work with the multi-format files. So it's not necessarily, that doesn't have to be restricted to relational. However, relational might be one of your data sources. So I might be running one job that actually goes to relational data sources as well as CSVs and do some analytical magic on it. It should allow you to put a data in an effective way in its raw format. So regardless if I'm looking at the CSV files, which are like, CSV, but kind of structure, well, it has tables, but not necessarily. But if we're looking at something more complex, like PDF or CAD drawings, right? I need those files unmodified at some stage. First of all, I don't want to have modified files at its origin, because that's kind of a source of different set of problems. So I need to land the data in its raw format. It would be great if it was unlimited. And probably if you go to cloud providers that give you things like blob storage or this kind of NoSQL databases that actually help you to land the data in a raw format, some of them will tell you it's unlimited. Well, let me put it this way. It should allow you to quickly scale. If the data grows, you should not be restricted to any tricky changes in the infrastructure. So if you go to AWS and go for S3, well, it's just going to grow pretty much to the limit of I don't know what. And you're just going to pay for what you use. Same with Azure. You go to Azure Storage, you create an account, you just keep dumping data over there, and you just only pay for the usage. And then the second component is analytics. So analytics has to be scalable. And this is really interesting because back in the days when we were running some kind of business intelligence on a SQL server, those two components were very, very tightly coupled. So my storage and analytics were pretty much defined by my SQL runtime, and I could put it on this machine with that many CPU, with that much of drive. Probably I could try to figure out how to scale it out, but Data Lake pattern actually allows us to disconnect those things. So I might have a different projects. One will require more storage, other will require more sophisticated analytics. And I need something that allows me to scale in both directions independently. So another thing about Data Lake analytics, because I'm talking probably to data in its raw format in many ways, I need to operate in some kind of a multi-protocol world. So it should allow me to read text files, CSV files, probably federate queries to SQL, and do other stuff that allows me to run jobs as close, run compute as close to the data as possible. Which brings us to actually compute data, which is one of the things that is interesting about the Data Lake analytics. When the first, when we started to experiment with clusters, the whole point was actually to bring the compute to data. So I don't necessarily have to load data to some kind of a relational database to run store procs on that. I actually had the data in a file system, and then I brought a cluster of like a Hadoop cluster or something like that, and actually run it very close to the data. And there's one more important thing about analytics, an analytics part of Data Lake, which is a schema on read. So once again, going back to the SQL world, we're kind of restricted with a schema on write approach. First of all, I have to model my schema so I can upload the data, so then I can work with it, which is a great thing for consistency, right? I can pick up things like problems with the data formatting or data formats or data types or something like that. However, when I want to push my analytics job, very close to the data, modeling your schema sometimes might become a very, very cumbersome. So today we're going to talk a little bit more about this bottom part and how that thing can actually be executed in a cloud environment. So one of the first approaches how to run those kind of jobs was pretty much using clusters. Does anyone use any kind of clusters, analytic clusters or HPC things? Hadoop? Spark? Redshift. OK, cool. HPC, love it. So let's just talk about clusters, right, for now. So how clusters support this kind of design pattern. So first of all, if I'm a client and I want to analyze some job, I probably would connect to something that is called a head node. Head node is a piece of my cluster that is responsible for negotiating what happens in the cluster. I might have more than one head node, but for simplicity, let's just talk about one head node. And I have multiple worker nodes. So those worker nodes, they give me two things. First of all, they give me compute power, and they give me some kind of storage abstraction, right? And I can actually, each of those things, you can consider as a virtual machine or as an actual machine, right? So I can easily scale the system. You can see straight away that, for example, if my workload becomes more analytical heavy, I might keep adding workers, right? Or I can remove them. And actually, one of the things that made people build clusters was actually the idea of having a lot of commodity software that hardware that no one used, and they just put it together, installed Linux and created the first resource negotiators and distributed file systems, and just start running analytical jobs. And this is how the first pre-ancestors of things like Hadoop were created. So what's going to happen when I actually want to run a job? First of all, my client, someone on the client puts some kind of job together. Probably in a Hadoop world will be like, I don't know, some kind of MapReduce job, or that might be a Scala, that might be PySpark or something like that. That thing is going to the head node, head node use something called the resource negotiation, say, hey, which of our worker nodes are actually free to take this job, right? And then this job is being, then the whole clustering magic happens, you know? So those worker nodes, so they will negotiate with head node who can take which partitions of the data, what kind of jobs, how to consolidate them, how to, you know, split them, and, all the magic will happen. It's all cool, but there's one problem with that. That's actually quite complex infrastructure. Because all you have, in order to build it by yourself, you have to have these machines, or you have to have these separate operating systems, and you have to make them talk to each other, and you have to figure out many things that actually make it possible. So that's why I wanted to talk about those 4 flavors of data lakes. And I want to split those 4 flavors by cluster maintenance. So how many things you have to do to make your analytical job somewhere that will pretty much follow data lake pattern, right? So I put this completely arbitrary 5 categories, kind of put them in the level of how close they are to metal and how close they are to running jobs, which are providing hardware, figuring out how the networking works, configuring your stack, which pretty much is what is your resource negotiator, what is your distributed file system, kind of like. The transferring data in and out to the cluster. The cool thing about clusters, when you put them down, you lose the data, especially if you do it in cloud. So you have to do a data transfers in and out, and then actually running the jobs. And in many times, I just don't want to worry about those 4 things. I just want to run the job. I want to quickly prototype. I want to realize what kind of problem I'm looking at, and then we can figure out what's the best approach, right? So flavor number 1, do-it-yourself cluster. You take what is on your rack, or you install Linux, you install Hadoop distribution, you try to figure out which versions are correct and which are compatible with each other. And once you're there, you probably have to, you can actually talk about, how to move the data to the cluster and how to run the jobs on it. Okay. That might be a lot of work if you are being asked to prototype something quickly. Or if you want to build your first data lake because you just want to understand how to operate with the data in this way. Another step is cloud hosted, right? So AWS and Azure, they have their own implementation of cloud hosted clusters. For AWS, this is called Elastic MapReduce, and for Azure, it's called HD Insight, which is a kind of, I think it's coming with the image of Hadoop Hortonworks data platform or something like that, which takes some pain away from you because first of all, in terms of hardware, all you have to do is specify how many workers you need and what's the size of the worker. The networking, once you spin up the cluster, the default networking will make those machines talk to each other. So that's there. The stack config is, unless you want to do something custom, you have a selection of couple of options you can use. And data transfer is a tricky one because the problem of the data disappearing out of the cluster is pretty much being mitigated by attaching some kind of a storage account to it. But you still have to be very careful if you finish running the jobs and you want to put your cluster down. You have to make sure what is the place that you're writing your data to. And finally, when you do all this stuff, you can run your job. Easy, right? Then there is a new player coming to the party, Azure Databricks. Who joined the previous Databricks talk? Was it good? Yeah. I was just preparing for this one and stressing out. So yeah. So Databricks is an abstraction on pretty much cloud-hosted clusters. You have a nice distinction between what is the job, what is the storage, and what is your cluster. And unless you do something really, really unusual, you don't have to worry about too many things, right? And Databricks probably today would be my go-to thing when I talk about data lakes. It's powered by Spark, it's pre-configured, it's really easy to operate, and it gives you a notebook to work with. So if you ever done any kind of data science work with things like a Jupyter or Zeppelin, you literally, you are being presented with a UI that you've seen already. You don't have to worry about some kind of, running jars over SSH or something like that. And then there is one more approach, the approach I'm going to demonstrate to you, which is serverless. And we have two products, two major players. Actually, there are three players. There is a cloud era as well. We have Azure Data Lake Analytics, and we have Athena. The good thing about those products is probably you don't have to worry about too many things. All you have to do is just spin up a resource in a cloud and run your job. Well, and upload the data or point it to a right data, right? But the principles of, for example, how Azure Data Lake Analytics works, it has its own data persistence. It won't allow you to save data in a way that will be lost on somewhere in the middle. And it nicely decouples, storage from analytics. So even the clusters, pretty much the storage of the cluster is limited by the hard drive of the cluster and the attached storage. However, for serverless, we have two separate components. One is responsible for compute, and second one is responsible for storage, at least for Azure Data Lake Analytics. I'm not very familiar with Athena. If you look on this scale, using something that comes more from the regular software development, that would be something, like talking about on-prem through IaaS, PaaS to serverless. It's not like, any of this thing is better than others. They have all pros and cons, right? But for some scenarios, you might just put yourself on a scale, and actually that thing might be my sweet spot. OK, so now I'm going to do a small segue to Dylan's talk from yesterday. So my job here is to show you how to run your first job without trying to understand what sits behind. If I succeed with that, then I'll be really, really happy. So let's forget about hardware. Let's forget about networking. Let's forget about data transferring. All we're going to do is just run jobs in Data Lake Analytics because, well, that's simple. So let's talk about how Azure implements serverless concept using Azure Data Lake Analytics. So we have those two things. One is called Azure Data Lake Store. Currently, we have two versions of it, but let's just simplify it and say, like, there's an Azure Data Lake Store. They say it's petabytes ready. I'm yet to see the limit of that. It's actually a combination of the object store and file system. File system addition for that is coming in the Azure Data Lake Store generation 2 is very, very handy when it comes to connecting, things like Databricks or Hadoop clusters that actually operate better on the file system. It supports some catalogs. So if you work with things like Hive, you'll find it familiar. That gives you a tabular model of your data. So once you, for example, ingest things like CSVs or TSVs or any file, you can land it in a tabular model. And this tabular model will support things like indexing, partitioning, distributions, and all this stuff. And it's HDFS compliant. So it's a Hadoop distributed file system compliant. You can connect anything that talks to, uses the Hadoop data file system protocol. You can connect to this store. And then we have analytics part. Analytics part is Apache Yarn based. So that's I think the most common resource negotiator these days that actually distributed the whole thing of that resource negotiator does. It makes sure that you can run your jobs and those part of the infrastructure is available to us. You program Azure Data Lake Analytics using something called USQL. Thank you, Microsoft, for coming with this name, because looking for reference of USQL is just, just try to Google USQL, and you have like a one USQL result, and then everything is SQL. Hey, did you mean SQL or not USQL? It's like, yes, of course. It has a local emulator, which makes things extremely helpful when you're not sure what you are doing. So you don't want to, put your credit card connected to Azure account and then run a job that will take $100. It's better to emulate it locally. And once you know what you're doing, you can lift this job to cloud. It has a Python and R support. And it has a nice thing called cognitive extensions I'm going to demonstrate in a second. So what happens in Azure Data Lake Analytics? First of all, I need my code, which is USQL. Then Azure Data Lake Analytics creates an execution plan that it's quite neat because it looks at two things: how your script looks like, but also how your data looks like. So you might have a slightly different execution plans for the same script if your data changes, right? Then this useSQL is actually being compiled to the mix of native C++ and .NET assembly, split into tasks called vertices. And those tasks are being deployed to analytical units. So these are your workers, right? These are the things that are running your jobs in the cloud. Simple. So what is useSQL and how do we start programming this thing? useSQL is a language that comes from an internal Microsoft big data project called Scope. Pretty much there's one PDF that tells what Scope is, unless you know someone in Microsoft who can explain you more. Like, I have no idea what Scope is. They just say it's Scope. It's inspired by SQL. So there is a reason why we're saying SQL. It's a declarative language. And actually, it's quite neat when it comes to working with data. If you can work with the data in a way that you work with SQL or with Hive. So in a declarative way, I would like to see what I'm programming to in a way that what I expect to see. It also has a similar metadata system in terms of talking about things like partitions or indexes. But underneath is actually a .NET language. And useSQL is a mixture of SQL and C#. So I will go through a couple of examples shortly, and you will see that that's not necessarily SQL that I'm using. Some of those hacks that are coming from C#. And if you are a C# developer, then probably that will look very familiar to you. And finally, to make it ready for a big data, there's plenty of things that were coming from a Hive world, and Hive being one of those things that are very strongly settled in the big data analytics. Some of those patterns were taken to useSQL as well. So useSQL looks pretty much like this. It has the two mandatory blocks. One is you have to extract data, and you have to land it somewhere. Interesting thing is those compilers, those useSQL compilers, those transpilers that are actually running through the useSQL, they will be smart enough to tell you whether some jobs are not resulting in a data that you put somewhere. So this is the problem of moving data in and out. And this is a compile error. All the processing jobs that you're running within one script have to end in some kind of result data set or in a catalog. Otherwise, you'll be burning money on just things that you don't need, right? And there is one thing, like literally you can do extract and then load somewhere, and then there's this transformation part. I kind of named this on purpose. And this is my emphasis of what data lake means to me. To me, data lake doesn't mean a replacement for things like a data warehouse or a place I'm storing data. To me, data lake is closer to ETL. It's something that helps me to process and transform the data to the way that I would like to, run reporting on or do something, put some smarts. It just pushes those analytical thing closer to the data as opposed to, let's say, a traditional business intelligence pipeline, right? However, those things remain the same. I need to get this data from somewhere, and I need to transform it in a way, to the format I want, and then I have to put it. So I want to mention this for one more reason. Probably, if you go to Databricks documentation, which is freaking amazing, you will find that there are concepts like ETL 2.0. Right? This is the new age ETL for cool kids, right? So this is all it is about, right? It's a big data analytics used as a transformation pipeline. So something that you were probably done in things like SSIS. It's completely possible in things like Azure Data Lake Analytics. It's possible in Databricks. It's possible in other approaches, right? So this is the beauty of being a data engineer in 2018, that you can look at those blocks and you can say, okay, this works better for this thing, and this works better for this thing. So let's just mix and match and see how we can do it. If we're looking at unstructured data, probably we have to look at the things like Azure Data Lake Analytics or Databricks. OK. That's enough of me talking about and showing you code on the screen. So let's do something in Azure Data Lake Analytics. Whoops, not yet. So I'm going to switch and demonstrate. I prepared a small demonstration for for the purpose of this talk. And let's start from Azure Portal. So Azure Data Lake Analytics, being an Azure resource, is pretty much something that, well, one of the way of creating it is using Azure Portal. And pretty much all you have to do to start running your first job is to create data, to find a new data lake analytics resource, get it from marketplace, pretty much give it a name, set it, find the region and resource group, and that will be it. It takes a couple of minutes to spin up, so I'm just going to use the one I already have. And Azure Data Lake will come with these two components. This one, which is Azure Data Lake Analytics, and the second one, which is Azure Data Lake Storage, currently called Storage Gen 1 because there is a Storage Gen 2 coming. Right? Everything else, what you can see in this resource group, is kind of optional and something that I was playing with to show to make sure that all the connectivity to different services work. So let's talk about Azure Data Lake Analytics first. Azure Data Lake Analytics in Azure Portal is pretty much your dashboard to look to manage it and probably see what kind of jobs are being executed and who has an access to this thing, and what are the security settings, things like a firewall, things like a pricing tiers, things like access control. So everything that makes this resource enterprise ready, right? It's not some kind of a hand-rolled cluster. I can go to a client and say, hey, if you're running Azure Active Directory, I have a data lake implementation for you that supports role-based access control. And they say, oh, that's interesting, right? Because I don't have to map my permissions or things like that. So that's the first place to go to actually start working with Azure Data Lake Analytics. And if you go there, if I happen to inspire you and you go and get your subscription or run it your existing subscription, a new resource like this, I really encourage you to go to this Getting Started session. And I think Azure, the Data Lake team, put a lot of effort to make this thing extremely easy to learn. So if you go to things like a quick starts, there will be a couple of examples of actually how to start and what are the sample jobs look like, and you can run it straight away on this resource. There are interactive tutorials, including videos. If you want to actually make it more mature solution, something that is automated and scripted, there will be samples for PowerShell and Azure SDK and how to run it through different tools. But the cool thing is actually when you look at the sample scripts and the interactive tutorials. So probably a website log analysis is something that many data lake applications is being applied to. So there is a sample data quite large, like large enough to show the benefit of this approach. And then you can actually start playing with it using things like a sample scripts. And that comes extremely handy. And look, I've tried to enter a big data word for a couple of times in the last couple of years. And scratching my head trying to figure out how to put a Hadoop stack together was not a very easy thing to do. I found this one as something, hey, finally I understand how it works. Hey, I finally understood what is the purpose and why those things are working the way that you put them together. And then there is this, once you do and, for example, go through those samples, there is this one nice button hidden here. And I have no idea why it's here, because pressing this button will install all the cool extensions into your Azure Data Lake. What it will do, it will give you Python support, it will give you R support, and it will give you something called cognitive extensions. And cognitive extensions is, have you heard about cognitive services? Right? Okay, so cognitive services, we have those APIs, we can train things in the cloud, then we can call those APIs. And recently, we can even download TensorFlow models deployed on some kind of mobile devices, right? So cognitive extensions actually take some of those models and put it in your data lake so you can call them directly. It will literally drop like a few hundred megabytes of linear algebra to your data lake store. So you can run it very, very efficiently without need of, let's say, implementing your own, TensorFlow wrapper or, going through a REST API. Okay. So let's look at uSQL right now. I created a couple of jobs, and yeah, on my previous talk, someone told me, hey, before you go into jobs, explain what you are analyzing. So yes, I'm going to do that. I created a couple of jobs based on the Kaggle data set. So this is a data set of donations to schools in the US. It has a couple of things like school name, school state, school city, who are donors state, and what kind of resources the school requested, what are the schools, who are the teachers, and the kind of a different things. So altogether, once you unzip it, it's probably 3 to 4 gigabytes of data. And it's a fairly unstructured thing, so you will find like a string encoded unique values, then states, and all the geographical data about the schools, and some numbers about donation amount, what was the status of this donation. And look, if I were to analyze this data in SQL, first of all, I had to do is actually go and try to figure out how to build a schema for this thing. I have no time for that. So I'm just going to load CSV and use this cool thing called schema on read and try to infer schema as I'm reading data. So I created a demo that actually, what it does, it uploads those data sets to the catalog. So the catalog gives me a certain benefit of performance because I will use indexing and distributions. And also, I will save some time on actually parsing those files, so the data will be sitting in a much more efficient format to be queried. And then I'm going to do two things. I'm going to look at the donations in terms of geography. So I will look how many schools in which different US states were given donations. And then I'm going to use cognitive extensions to actually run a sentiment analysis, because I would like to know more about, like, probably I don't want to go through, this couple of hundred of thousands of essays and descriptions of why they were, requesting for the money, but I would like to do some cool analysis saying whether your tone of your language were, positive or negative, or what were the key phrases, what were the things you were looking for, in your request, right? So if you look at the script, it's pretty much starts with. Let's just go with the upload donations. It starts with me extracting a CSV file. So I have things called extractors. I have a CSV file, and I'm taking those CSV files from my either local or remote machine and actually uploading them to a schema. So if you don't love uSQL by now, I'm just going to show you this thing. Drop table if exists. Think about SQL now. Please think about SQL now. Then you have create table if exists, create schema if exists, right? So this language is really, really friendly when it comes to building those things. And I'm not probably a SQL guru, and I want my things to be done very, very quickly. So that's the one thing. The other thing is I can create a table from my results set. And I define my results set in things like, plain C#, actually, right? So I have a C# types. I'm reading my CSV. At this point, there is some schema validation happening. So for example, if this thing becomes null, the job is going to tell me, hey, I wasn't able to parse a null value to an int, right? So I could just do, okay, nullable int, and that's going to work. But actually, this is quite like, if we're talking about data quality, probably putting but putting constraints, close to the data is something that I would like to do to just understand more about what might be a data issues that I'm looking at. And then I can look at it and actually put it to a catalog. So if I don't do any transformation, I can literally do select star here. And my data is going to be created in a schema that I just infer from a CSV file. However, we're talking .NET, so I'm just going to do some kind of, I'm going to do a very simple transformation because the donation was a flag that was saying yes or no, so I'm just going to use a plain C# to run some kind of quick transformation. So that's a C# conditional expression, and that actually is going to map this string to Boolean, so that will save some storage probably, and will help me to index it better. And I've done something else so something like this for another data set. And I'm doing it for all the data sets that are there. They're just a different size. I wanted to run them in a different order. So I'm not necessarily, some of them were probably 100 megabytes, and it takes a couple of seconds to upload them. The other one was almost 3 gigabytes and takes a couple of minutes. That's why I have them in a couple of files so I can run them independently. So probably uploading data to a catalog is one of the most boring things you can do. So I'm just going to go straight away to the jobs I prepared for this talk. So if I want to run a job, I have two options. Or actually, I have a couple of options. But my first option is running on a local machine. So this is my local Azure Data Lake emulator. That's literally what's going to happen is when I press this button, please work, that is going to compile all those things into Vertex. Create all those Vertex definitions, these tasks, create a small executable file, and run it in an emulator on my machine, right? So I don't have to even spend a single dollar in Azure to start experimenting with this. So, yep, that just happened. It created a result set. I can go through this result set, and I actually can see what this result set was. What this output data set was saying. Hi, Visual Studio. Okay. The other option I have is actually run it in cloud. So I have a couple of those resources attached to my different subscriptions, and I can actually run it in cloud. So if I want to run it in cloud, I have to pick my Azure Data Lake Analytics account. I have to pick the number of analytical units. So these are the workers. And by the last public release, which happened in 2016, of how large one AU is probably 2 cores and 6 gigs of RAM. So if I put something like that, I'm talking about 20 cores and 60 gigs of RAM available for this job. If I put something like this, I'm talking about 200 cores and 600 gigabytes of RAM to run my job. And I can play with that. But probably, well, I don't want to pay too much. I'm just going to run quickly, let's say with 5. And now what's going to happen, I'm submitting this job to Azure Data Lake Analytics, right? So that's going to run for a couple of seconds. And I told you that my Azure Data Lake Analytics is a dashboard that I can use to monitor these jobs. So I'm just going to quickly go here and go to View All Jobs. And you can see that I just submitted a work in here, a job in here, right? And I can monitor it from this one. I have 5 analytical units. This is a USQL type, durations, and it's preparing, right? And I can click on it, and I actually can see what's going on inside. So each of these jobs will have 4 stages. One is a preparing. This is pretty much a compilation and verification of the data. So up to probably running, you don't pay for how long it takes. So preparing is just a compilation. Queuing is putting it, making sure the resources are available, and then running it and done and completing is pretty much the execution and putting data back. Okay, so the job is prepared. And this 1 minute, like some of you might think, okay, why do I want to run a job that takes 1 minute to prepare when in SQL, all I have to do is run a script and it's just going to execute immediately. This preparation time is actually creating the optimized plan to run your data. And I'm running a fairly simple jobs that are taking for a couple of seconds, right? You can, when we're looking at the workflows that probably will run over those terabytes of data trying to tag or extract something data from your PDFs or something like that, you can spend this couple of minutes to make sure you're not spending more hours, right? So that tries to optimize this job and then finds resources for me, and then actually run this job in the cloud. And what's going to happen shortly, once this job is complete, we're going to see something called a job graph. And job graph is actually my execution plan. So for you who are sitting a little bit further, I'm just going to go to Visual Studio, because you can see the same job graph in a Visual Studio. That's literally an iframe. And I can go and actually understand how my job was flowing. So I started to analyze 200 or over 2 gigabytes of my donation projects. And I kind of joined it, I joined it with the school data. I can see how many data was filtered and how many flow. And one of the most interesting thing about this piece of technology is put yourself in a situation that you already engineered your job and it has a couple of hours to run. So probably you're not going to see and look at it for a couple of hours. Like that's like procrastination, I'll say. So if I load the profile of this job, which is kind of, profile of the job, I can actually play it back. And please name one debugging tool that gives you an animation. So that was a couple of seconds worth of work. However, I have something that runs those text analytics that takes around 10 minutes on a kind of limited subset. And I actually can do the same thing. So I can play back this job and actually understand how my data was flowing and how my AUs were utilized to make sure that I'm paying for what it's worth. I can change it from progress to things like time, so generate a heat map of different places that were consuming most of the time for this job. I can look at the data read and data written. So if I'm looking for things like a data skewness, which data skewness is this phenomenon that happens when your partitioning or distribution strategy makes your analytical units to be distributed in a way that some of them are very busy and some of them are not doing anything but charging your credit card. You can actually start inspecting for those problems in here using this tooling. Also data written, right? And eventually, on the bottom of this thing, I will have data sets that were produced, and I can debug this thing, right? So being quite fresh to this world, I was given a tool that allowed me to jump very quickly to this concept and understand how it works under the hood. And I didn't have to think about operating systems or networking. I wanted to understand this big data workflows, how they work, how I can actually visualize those concepts. So Azure just recently added, Microsoft just recently added to Azure something called AU analysis that actually helps me to save money. Thank you, Azure. So if I go to my recent job, and on purpose, I picked 5 analytical units because I knew that's kind of a lot for this job. This graph actually shows me how my 5 of analytical units were utilized for the work. So once again, I don't have to think about my infrastructure, yet I have all the tools that I need to inspect this infrastructure, right? And I can pick, those, and I can tweak it. I don't have to think about how many nodes connect to my cluster. All I have to do is pick the number of analytical units that I'm using for this job. And then I have some kind of suggestions saying, hey, you actually picked 5 units, and we estimate efficiency 18%, whatever that means. And you paid 20 cents for that. But if you picked 2 of them, you would pay 9 cents with efficiency 62. And your job would take 10 seconds more. And then I can run those simulations, and actually it will try to simulate what would be the effect. So the first line, I shouldn't be crossing this line. The first line actually tells me how the job was running. And the second line is kind of a projected how it would do if I run on 2 analytical units, right? And how much money I would spend. OK. Another really interesting thing is a diagnostics that actually gives you all these notifications about, hey, do you have a data skew? Do you have a time skew? Your AU analysis haven't been overspending and this kind of stuff. And actually, it's quite smart about picking up those bad practices straight away. OK. So the effect of this job was, this is Power BI. If you haven't seen it before, Power BI has a connector to Azure Data Lake storage, so you can just plug it and start looking at the data. So what we've done here by running these jobs, we actually analyzed what is the distribution of the donations across the US. So most of the money goes to California and New York. And we can interactively, look at this data in details and actually understand which schools get, or which states and cities get most of the school funding. And the second job was actually, I wanted to run this fun experiment saying, hey, whether this, a sentiment of the request makes, easier or harder to get a funding. It doesn't. So this is sentiment and donation amount. So this is donation amount from 0 to 14,000 for people who can't see this scale. And this is the sentiment, which is positive to negative. So probably it doesn't really care if you rant or you're extremely happy about your request, you're still going to get money. And then I picked up a couple of key phrases. So this is everything done in Azure Data Lake Analytics, pretty much, using these two jobs. Looking at the top key phrases, things like they were looking for some kind of funds for technology and reading and hands, whatever that means, books, maths. So happy to see a technology and maths on the list of the top 20 things they were asking for. OK. So that's pretty much end-to-end journey from Kaggle running in Azure Data Lake Analytics without thinking about clusters to something that you can present and say, hey, this is output of my analytics, right? And you can do it with Azure Data Lake Analytics quite quickly. How much time do I have? Right, 8 minutes. OK, so I wanted to show you something nerdy. I told you that all those jobs and execution plan are actually being compiled to a combination of C++ and native and something like this. So actually, I've downloaded one of those jobs you can download them and run it in Visual Studio and debug them. And this is one of those jobs. This is one of those text analysis jobs vertices. And you will find in it things like those DLLs, source code in C#. You will find debugging files. You will find some kind of descriptions. You will find, bunch of C++ code that makes it so fast. And because this job actually required using cognitive extensions, which is those pre-trained models to do a sentiment analysis and keyword extractions. Also, it does things like face detections or OCR, very fundamental machine learning approaches, I would say. Not fundamental, but generic. It actually downloaded it so I can debug it locally. And you can see, there is a bunch of things like a natural language processing, libraries, plus plus things like train models, right? So this was one of those models that was used during the key phrase. So everything is there, available to you. You don't have to, plug it to another service. You can just run those things. And from code it looks something like this. So hey, from my donations project, schema support, right? From my master database donations project, get me 5% of the data because, well, this text processing takes some time. I'm looking for project ID and description only for fully funded. And then on this result set, process this result set with key phrase processor on the column description and give me description and key phrases as a SQL array, right? And then you can cross-apply, explode this array to make sure that, they're not take an attempt to optimize to normalize it. Same thing for sentiment analyzer, right? So from cognition text, sentiment analysis, just run sentiment analysis on this description, right? And then output it to a CSVs, and then I have a Power BI plug to those CSVs in cloud. Okay, let's go back to this thing. Is that going to start from the beginning? Oh, dear. Rookie mistake. So just to quickly recap. So executing SQL Azure Data Lake analytics takes SQL compiler that looks at both at the code and the data and try to optimize this job. We have those job graphs that allows you to do, all this debugging and replace and, looking at those things. Also, they allow you to do side-by-side comparison. So if you have two jobs that differ slightly, it's going to show you a diff, kind of like a Git diff thing. We have tasks that are a combination of managed and unmanaged code, and they're when you look at them, that will be described as vertices. We have a query store, so this is the place when we can go and actually pick all the historical jobs and get their details and get their debugging profiles and stuff like this. And we actually scale this thing using the number of AUs, and we have a nice recommender to do it. Okay, so why should we bother about it? First of all, you can focus on running jobs, not maintaining infrastructure. Maybe if you have a data workload that justifies, standing machines. And by the way, Azure Data Lake Analytics from the pricing model is you pay for what you run. This resource, when I'm not running on it, doesn't cost me a single cent. If I run a job, it just takes, okay, you just run a job for 15 seconds or for 15 minutes. The 1 hour of running those jobs is that many dollars. This is how much you're going to pay probably in most case. In my case, it's a couple of cents. So pay for what you use, and you might have a workload that justify, standing clusters, or you might want to design a workflows that uses some kind of, commodity hardware that you have in on your rack. But if you just want to quickly jump in and, try your strengths in the big data analytics in those kind of approaches, this is thing that actually worked really well for me to explain some of those fundamental concepts. It has a .NET and Python support, so you don't have to be great at Python. You don't have to understand things like NumPy or Pandas or anything like that. You can go there and just use a mixture of SQL and C# and start playing with your data. The tooling and documentation is, I've shown you just couple of tools that are available. You can also use it in Visual Studio Code. So there are plugins for Azure Data Lake Analytics in VS Code. Those plugins work with Visual Studio Community Edition. The difference would be some of the features that are in the preview what won't be available in the Community Edition, as opposed to Visual Studio Professional. But VS Code, Community, you will have a level of tooling. The documentation is maintained quite regularly, and it's enterprise ready. So you have all those, like if you go to a client and say, hey, I would like to run this job, and they start asking questions about security, firewalls, role-based access account, making sure that only the right people can access those kind of data set. Everything is there, right? You don't have to think about how to redo all this stuff. So I don't know, probably if you want to take those, there are a couple of references I used during this when I was researching this talk. So if you're interested, just take a snap of this one, and I'll be wrapping up. Questions? Oh, okay. This person over there that I don't know. The question is, can we plug our custom models to it? So I've actually wanted to learn more about how those cognitive services, cognitive extension work, and this is just a pile of .NET running on top of the .NET. So if you're really interested, I can probably we might spend some time, and I'll show you how to do customizations and write something a little bit more sophisticated in this. So everything here is .NET, right? And all you have to do in order to run, say, your TensorFlow model, you have to wrap it in .NET, and you have to land it in your Azure Data Lake store, and you have to make sure that pretty much you're not using some kind of dodgy dependencies that probably might crash. If you're using pure .NET, and if everything is kind of a self-contained, you can land it in a very similar way that cognitive extensions are being landed, right? So I haven't tried. I don't see limitation. I've just, tried to reverse engineer how they execute it. Other questions? 3, 2, 1. Cool. Thank you.